Hello everyone, welcome to this video. In this video we are going to learn time, speed and distance, and we are going to cover the relative speed and the train problems in this video. So let's get into it. What is relative speed? You must have traveled in train, isn't it? When we are in one of the trains, and let's say this train is running with a speed of 60 km per hour, another train is coming from the opposite direction. Let's say its speed is also 60 km per hour. When you look at the other train, you'll feel like that train is coming with a speed of 120 km per hour, not 60. You'll feel it is 120 km per hour. Why 120? Because when the two bodies are in the opposite direction, the relative speed will be the summation of the two speeds. In the opposite direction, speed gets added. But when the two trains are in the same direction, the speed gets subtracted. Okay, so let me just repeat it. When two bodies are in the opposite directions, the relative speed will be S1 plus S2. But when the two bodies are in the same direction, the relative speed will be S1 minus S2. Let's say the distance between two stations are 120 km. One train started from station A at 40 km per hour. Another train starting from station B at 20 km per hour. And because they are in opposite direction, relative speed will be 60. But both of them must be starting at the same time. Let's say they are starting at 10 a.m. Because they both are starting at the same time. At 10 a.m., the distance between them is 120. So when we apply the relative speed, the time is the distance between them at 10 a.m. and the relative speed starting at 10 a.m. that is 40 plus 20. It is 120 divided by 60. That is 2 hours. After 2 hours, they will meet each other. But if one of the train was not starting at 10 a.m., then we cannot apply the relative speed. To apply the relative speed, the time of starting must be same. Keep that in mind. Let's take one example for that. A train starts from A at 8 a.m. Okay, 8 a.m. and travels towards B at 60 km per hour. All right. Another train starts from B at 9 a.m. and travels with a speed of 75 km per hour. At what time they will meet? Now, this train starting at 8 a.m., this train is starting at 9 a.m. The starting time is not same. But as I told you, to apply the relative speed, for this case, it is opposite, so S1 plus S2. To apply that S1 plus S2, the relative speed, we need to find the same time. Okay, here it is 8 a.m., here it is 9 a.m. So what we'll do is, we'll apply the relative speed at 9 a.m. At 9 a.m., this train has already covered 60 km. In 1 hour, the speed was 60, right? So in 1 hour, it has already traveled 60 km. So what is the remaining distance now? The remaining distance is 330 minus 60. It is 270 kilometers. At 9 a.m., the distance between them is 270 km. For this distance, now both of them are starting at 9 a.m., 9 a.m. So now we can apply the relative speed. So the time taken to meet will be 270, the remaining distance, divided by 60 plus 75. This is 270 by 135 km per hour. After 2 hours, they will meet. So because we are starting at 9 a.m., 9 a.m. plus 2 hours, the time at which they will meet is 11 a.m. Option C is the answer. Let's move on to the next problem. 20, 30. By the time they meet each other, Q has covered 36 km more than P. Okay. Started simultaneously, right? So they're starting at the same time. And when they meet each other, they're reaching here at the same time, isn't it? Starting time same, ending time same. And when the time is equal for both of them, we can say the distance will be directly proportional to their speeds. Okay. So when the speeds are in the ratio of S1 by S2 is 20 is to 30. The distance ratio will also be same for both of them. D1 and D2 will also be 20 is to 30, that is 2 is to 3. But the difference between them is 36 kilometer, correct? So if I take this as 2x and this one as 3x, 3x minus 2x is equal to 36 kilometer. X is 36, that means the first person must have traveled 36 to just 72 and second person must have traveled 36 3 are 108 kilometers. So total distance will be 72 plus 108, that will be 180 kilometer. Let's move on to the next problem. Police is here, thief is here. The distance between them is 200 meter. And the speed is 10 and 11. The relative speed, because they are in the same direction, the relative speed of police and thief will be 11 minus 10, that is 1 kilometer per hour. So distance traveled in 6 minutes will be 1 kilometer per hour into 6 by 60 hours, because it was 6 minutes, right? So I converted that into hours. 6 by 60. It is 1 by 10 kilometer or 100 meter. So 100 meter the police has already traveled as compared to thief. So now the distance between them is, distance between them at that time is now 200 minus 100, that is 100 meter. Let's move on to the next one. Now we'll talk about the train problems. In the train problems, the question will be, how much time the trains will take to cross each other. Somewhere they must have started crossing and finally they have already crossed. Look at the diagram. When they started crossing, they are meeting for the first time. Or in another word, I can say the engines are together. I'm taking the engine as a reference to understand it clearly, okay? So when they started crossing, the engines are together. The distance between engines are 0. When they have already crossed, now the distance between engines are L1 plus L2. So initially the distance between engines 0, finally the distance between engines are L1 plus L2. So how much distance they have to travel to cross each other? That is L1 plus L2. We have the distance now. Relative speed we can easily find, right? When they are in opposite direction, S1 plus S2. When they are in same direction, S1 minus S2. That we can easily find. Let's apply that. So by applying that, we are getting time taken to cross each other is equal to L1 plus L2 divided by S1 plus minus S2, depending on the direction in which the two trains are moving. Now I want you to mug up only this one formula, because if you remember this one, other formulas will come automatically. Other formulas like the train crossing a lamppost, the train crossing a man who is stationary, the train crossing a man who is moving, the train crossing a bridge, platform, all those formulas will come automatically. Let's say I talk about the train crossing a bridge or a platform. Both are same. Length of train, speed of train, length of bridge, speed of bridge. Speed of bridge will be how much? Obviously the bridge cannot move, the platform cannot move, so speed is going to be 0. Let's put all these values in this formula now. T is equal to, in this formula L1, L1 is length of train, and L2 is length of bridge, S1 is speed of train, and S2 is 0. So the formula is coming automatically. T is equal to LT plus LB divided by ST. This is the time required to cross a bridge or a platform. Similarly, when the train is crossing a lamppost, the length of lamppost is 0. In the horizontal direction, the length is 0. The speed of the lamppost is 0. And that's why the formula will become L1 length of train, L2 length of lamppost, S1 speed of train, and S2 speed of lamppost. So automatically the formula is coming LT by ST. Time taken by train to cross the lamppost, LT by ST. Same formula will be applicable for man who is stationary. So all you have to do is check is whether L2 is there or not, because L1 is going to be length of train and S1 is going to be the speed of train. That is not going to change. The only thing we have to keep checking every time is the second thing, whether it's bridge, platform, lamppost, stationary man, whatever it is L2 there or not? Is S2 there or not? check only that much. From that itself, automatically the formula will come. Let's try to solve some problems based on this. Train and platform are equal. If with a speed of 90 km per hour, train crosses the platform in 1 minute. Okay, then the length of the train is, fine. Time taken by train to cross the platform. Length of train plus length of platform, because both are equals, are taken LL, divide by speed of train, but this is in kilometer per hour. Convert that into meter per second. And this is already given 1 minute. 1 minute means 60 seconds. So we get 2L divided by, this one was 90 into 5 by 18. This is 25 meter per second is equal to 60. So 2L is equal to 60 into 25 by 2. This will be 750 meters. Let's go to the next problem. The train passing a bridge was length of train plus length of bridge divided by speed of train. That is, first time 100 seconds and second time it is length of train plus length of bridge divided by speed of train is equal to 60 seconds. From equation 1 we are getting L 100 st minus L is equal to 800, and from the second equation we are getting 60 st minus L is equal to 400. And when we solve these two, L cancelled and we have 40 st is equal to 400. So speed of train is 400 by 40, that is 10 meter per second. But they're asking the length of the train. So the length of the train will be, when you put this value st equal to 10, we get 60 into 10 minus L equal to 400. So L will be equal to 600 minus 400, that is 200 meters. Let's move on. Do you remember, when the train passes a bridge, it has to cross its own length LT and also length of bridge. Both it has to pass. For this it is taking 20 seconds. But when it has to cross the lamp telegraph post, it has to cross its own length. For that they are telling 8 seconds. So for LT it is taking 8 seconds. For LB how much it will take? 20 minus 8. So if the time is 12 seconds, the length is already given, length of bridge is 260. So the speed will be, speed of train is equal to 264 divided by 12. This is 22 meter per second. And when we convert that into kilometer per hour, this will be 79.2 kilometer per hour. That's all in this video. Thank you so much for watching. Please like, share and subscribe. The next video is going to be about boats and steams. The link have been shared in the description below.